you to the fifth class of this theory of relativity. In this class, let us solve some examples. So let us solve first a short type of examples which can be asked as 2 mark questions. See, your first example is an aeroplane is moving with uniform velocity, means v is given, of 600 meter per second. With respect to the earth, by what fraction of its length will it appear to be shortened to an observer on earth? Means L upon L naught is asked. You know that L is a change in length, L naught is a proper length or its original length. You know that your formula is L is equal to L naught into square root of 1 minus v square by c square. From this equation, your L is upon L naught. L upon L naught is equal to square root of 1 minus v square upon c square. What is c here? You know that your c is velocity of the light, which is 3 into 10 raised to 8 meter per second. You know v is 600, you know c, you can calculate what is L upon L naught. Now this is your first example. Now let us go to this second example. A body at rest mass m0 is moving with a velocity of, that means v is given, velocity of how much? Root 5c divided by 3, where c is the velocity of the light. Calculate its mass, means you have to calculate m. So what formula you are going to use? Yes, you know that m is equal to m naught upon square root of 1 minus v square upon c square. So first you calculate this one. So your v square is 5c square upon 9. Then you substitute in this formula. This is your m is equal to m naught divided by square root of 1 minus, for v square you are writing it as 5c square upon 9, and this is c square get cancels. So you calculate m in terms of m naught. So if you simplify, you are going to get this as m is equal to 3 by 4 of m naught. This is your second example. Now your third example is when 1 gram of mass is completely converted into energy. That means your third example is m is given 1 gram. This is in kg, all right. 1 into 10 raised to minus 3 kg is completely converted into energy. Calculate the energy released in SI unit. So they have asked what is E. E is what? You know that E is equal to mc square. E is equal to mc square. M is 1 into 10 raised to minus 3. 1 into 10 raised to minus 3. Again your C, you should know it is 10 raised to 8 whole square. If you simplify this, this is 10 raised to minus 3. It is 9 into 10 raised to 16, or this is 9 into 10 raised to 13 joules. Now the fourth example is, in Michelson-Morley experiment, the distance traveled by the light of wavelength 6 into 10 raised to minus 7 meter is 10 meter. So this is fourth example. Lambda is given. It is 6 into 10 raised to minus 7 meter. Distance is 10 meter. The orbital velocity of the earth is v is given. Earth is 3 into 10 raised to 4. Meter per second. And velocity of the light is 3 into 10 raised to 8. C is 3 into 10 raised to 8 meter per second. Calculate the fringe shift. They have asked to calculate fringe shift is what? You know that fringe shift after rotation through 90 degree means theta is 90 degree. They have rotated the entire apparatus. You know that when it is rotated, fringe shift F is equal to 2 dV square upon lambda c square. So you substitute the value of d, v, lambda and c. You are going to get this fringe shift as 0.3. So such a type of examples will be asked in section A, which carries 2 marks. Now let us solve some 5-mark examples. See, the first example is an observer on the earth measures the length of a moving spaceship to be exactly half of its length. That means L is equal to L naught divided by 2. Calculate the speed of the spaceship. V is what? And the time dilation corresponding to 1 second on spaceship. That means T is what? given it is T naught is equal to 1 second. So you know that first you have to find out what is V. L is equal to L naught into square root of 1 minus V square by C square. So given that L is L naught upon 2, this is L naught upon 2 is equal to L naught into square root of 1 minus V square by C square. This L naught cancels. Then if you square this equation, it is 1 by 4 is equal to 1 minus V square by C square. If you simplify this, you are going to get it as V is equal to 2.59 into 10 raised to 8 meter per second. Now you got this V as 2.59 into 10 raised to 8 meter per second. Then for time dilation, second one, this is first, and second one, for time dilation, this is T is equal to, you have to write it is T naught divided by square root of 1 minus V square by C square. You know the value of V, you know the value of T naught is 1, then if you simplify this, you are going to get T as 2 seconds. You simplify this. Time dilation is 2 seconds. Then see the second example. If the mass of a particle in motion is exactly thrice its rest mass, that means m is equal to 3 times m naught. Calculate the velocity of a particle. So you have to calculate what is V. What is given? Velocity of the light, that is c, is equal to 3 into 10 raised to 8 meter per second. Then you have to use this reducible mass formula. This is m is equal to m naught square root of 1 minus V square by 2. Sorry, V square by C square. Then m is given, it is 3m naught. This is equal to m naught upon square root of 1 minus V square by C square. M naught get cancels. What remains? This is 3 is equal to 1 upon square root of 1 minus V square upon C square. Again square both the side. Finally we are going to get this V as, it is 2.82 into 10 raised to 8 meter per second. Now the third example is two spaceships X and Y are moving in opposite directions, each with a speed of 2.4 into 10 raised to 8 meter per second. That means here this is ux dash is 2.4 into 10 raised to 8 meter per second. Then V is, because they are moving in the opposite direction, minus 2.4 into 10 raised to 8 meter per second. Find the relative speed of y with respect to x. That means they have asked to find out what is uy. Given the velocity of the light is 3 into 10 raised to 8, v is equal to 3 into 10 raised to 8 meter per second. Then the relative speed of y with respect to x is given by ux dash, then minus v upon 1 minus v square by c square. It is square root of 1 minus v square by c square. Now let us solve this third example. Two spaceships X and Y are moving in opposite directions, each with a speed of 2.4 into 10 raised to 8 meter per second. That means in the third example it is given that ux dash is 2.4 into 10 raised to 8 meter per second. Find the relative speed of y with respect to x. That means here v is minus of this, since they are moving in the opposite direction with the same speed. Find the relative speed of y with respect to x. That means they have asked to find out what is uy. Given that velocity of the light, that means c is equal to 3 into 10 raised to 8 meter per second. It is a relative speed. You know that relative speed of y with respect to x is given by ux dash minus v divided by 1 minus ux dash v upon c square. Then if you substitute, this becomes uy is ux dash is 2.4 into 10 raised to 8 meter per second. Minus of minus becomes plus. This is minus. It is 2.4 into 10 raised to 8. That divided by 1. Again this becomes plus. 2.4 into 10 raised to 8 into 2.4 into 10 raised to 8 divided by c square. 3 into 10 raised to 8 whole square. If you simplify this, you are going to get this ui as 2.92 into 10 raised to 8 meter per second. Then similarly this fourth one, if two particles move in opposite directions along x-axis with the speed of 0.7 c, that means here ux dash is 0.7 c, velocity to the light. Now what is it? Definitely v. V is minus 0.7 c. With respect to the laboratory, calculate their relative speed. Means they asked to find out what is your u. Then what is your form? Same formula, u is equal to ux dash minus v upon 1 minus ux dash v upon c square. Your v is given and ux dash is given. If you simplify this, you are going to get this as 0.93 c. You calculate this at home. Now the fifth example is, two particles are moving along a straight line towards each other with uniform velocities. Again, this is u1 ux dash is 0.8 c and 0.5 c. Let us take this as negative. Respectively, calculate the relative velocity of approach between them given velocity of light, that is c is 3 into 10⁸ meter per second. Now once again you have to use this relative velocity of approach. Relative velocity of approach. U is equal to ux dash minus v upon 1 minus ux dash v upon c square. Then this is 0.8 c plus this you should take it as minus 0.5 c divided by 1 plus, because of this negative sign, see your fifth example is, two particles are moving along a straight line towards each other with uniform velocity 0.8 c and 0.5 c towards each other. Means ux dash is 0.8 c and v is minus of 0.5 c. Calculate relative velocity of approach. That means u is asked. Between them, given velocity of the light is c is equal to 3 into 10⁸ meter per second. Now what you have to do? Same formula. Your relative velocity of approach is given by ux dash minus v upon 1 minus ux dash v upon c square. Then you substitute ux and v. So this is ux is 0.8 c. Then this becomes plus 0.5 c divided by, once again this is 1 plus, it is 0.8 c into 0.5 c divided by 3 into 10 raised to 8 whole square. Now we simplify this. If you simplify this right hand side, you will going to get the relative velocity of approach is 0.92 c. You calculate it at home. Then see the sixth one. Calculate the speed of the particle of rest mass. Now we have to calculate what is v. Rest mass is given. This is m naught is 3.33 into 10 raised to minus 27 grams. Now if you write it in kg, 3.33 into 10 raised to minus 30 kg. Whose energy estimated to be, energy is given, that means E is equal to how much? 2 mega electron volts. Now you write this mega electron volts in terms of joules. This is E is equal to 2 into 10 raised to 6 for mega and 1.6 into 10 raised to minus 19. It is for joules, conversion of electron volts into joules. Now we are going to get this E as, it is 3.2 into 10 raised to minus 13 joules. It is minus 19 and plus 6. It is 19 joules. You know that it is mc square is equal to 3.2 into 10 raised to minus 13. Your m is equal to, it is 3.2 divided by into 10 raised to minus 13 divided by c square, 3 into 10 raised to 8 whole square. Or this is m is equal to 3.2 divided by, this is 3 into 3 is 9. So this is 9 into 10 raised to 16 plus this 13. 16, 13, 26, 27, 28, 29 it is. It is 10 raised to minus 29. If you simplify this, you will going to get this as 3.5 into 10 raised to minus 30 kg. You know m and you know m dash. You can calculate what is V. By what formula? This is, it is m is equal to m naught upon square root of 1 minus v square upon c square. then your m is 3.5 into 10 raised to minus 30. This is m naught is 3.2 into 10 raised to minus 30 divided by square root of 1 minus v square by c square. If you simplify this equation, you are going to get this b as 0.92 into 10 raised to 8 meter per second, or your v is 9.2 into 10 raised to 7 meter per second. You calculate this at home. Now your seventh example is a rod of 1 meter long, means proper length is given, 1 meter, is moving with velocity of 0.6 c. That means velocity E of the rod is 0.6 c. Calculate its length. L is what? As it appears to an observer A on the earth, means rod is in motion, an observer is on the earth, two of them are in different frames of reference. So observer is on the earth means he is in the frame of reference which is at rest, and the rod is in motion in another frame of reference. That frame of reference is moving with velocity of 0.6 c. Then what is length? You know this L is equal to L naught into square root of 1 minus v square by c square. So your L naught is 1 meter into square root of 1 minus your v is 0.6 c. If you square this, it is 0.36 c square divided by c square. This c square get cancels. So 1 minus 0.36 is, it is square root of 0.64. Then what is this square root of 0.64? It is 0.8. This is 0.8 meter. Means length appears to be shortened. In the move with the rod itself. That means both, in the second part, both observer and the rod are in the same frame of reference. Means for an observer in the same frame of reference, that rod appears to be same. That means in the second case B, your answer is the length does not change. That is what it is, 1 meter. L is equal to L naught is equal to 1 meter. Then 8th one. If your rod of length 2 meter, means here L naught is 2 meter, is placed inside a satellite which is moving with a velocity of 0.5 c. That means velocity of the rod is 0.5 c relative to the laboratory. what is the length of the rod if the observer is in the satellite and second one is in the laboratory. So answer for first one is, it is 2 meter only. Why it is 2 meter? Because of satellite is moving with velocity of 0.5 c and observer is in the satellite. Both of them are in the same frame of reference. No change in the length of the rod is observed. Then in the laboratory, means satellite is one frame of reference, laboratory is another frame of reference. Satellite is moving with a relative speed of 0.5 c. So B, your length is L is equal to L naught, once again square root of 1 minus B square by C square. Then this is L naught is 2 meter, 1 minus your B square is 0.5 is 0.25 C square upon C square. This C square it cancels. This is 2 into square root of 0.75 meter. Then if you simplify this, you are going to get this as 1.732 meter. So such type of examples will be asked as a 5-mark question.